highlighter, and we have a new definition of what is a composite object. Well, if we can put two objects that we already know together, then we can probably solve questions with surface area and volume. So here is the first question. We have to look at the shapes that we have, and we want to find the volume. So in this question, we're going to need to find, we can write out a statement here, our total volume will equal the volume of a cylinder, that's on the bottom, plus the volume of a hemisphere. So I start off with the idea. I see my shapes, and I want to find that total volume by adding those two volumes together. So if I want to start with the volume of the cylinder, I go to my formula sheet, and I see that my volume formula for my cylinder is pi r squared times height. So again, write out the formula, and then you have to decide, do I know everything for this formula, or do I have to sometimes have to do extra math? For example, I could have given you the diameter. If I gave you the diameter and you need the radius, you have to do extra math by dividing by 2. In this case, we're given everything that we need, so we can plug those numbers in. The radius is 18, that's getting squared. The height is 32. So I can go to my calculator, type this in exactly as I see it. And you could put brackets, or you could put the times sign in between. And I get 32,572.032. There we go. And that answer, 32,572. All right. And you might, maybe you want to put a temporary circle around that for yourself. Now we're going to find the volume of our hemisphere. It's going to equal half of the volume of the whole sphere. So we go to my formula sheet, and I look at the volume formula for a sphere. And I plug in everything again. And again, practice typing these things in yourself. Right? You know how to write a cube button on your calculator. Can you write this all in exactly as it seems, and then push enter? 12,214.5. Temporary circle around that, and now my total volume, I'm just going to have to add the two things that I circled in green together. So it's going to be the 32,572 plus the 12,214.5. And again, I'm not rounding until the very end, to make sure that I don't make a rounding error along the way. Now, depending on your calculator, you might have to retype things in. On my calculator, I can just hit the plus button and says, it takes the answer that I had from before, and then I want to add, and I'll just scroll up until I get the other number. Saves me time typing it in. So all calculators have shortcuts built into them, even if you have a scientific calculator. Learning those shortcuts can be really helpful. And so we get 44,786. I'm going to round to 3 decimal places to start, and then I'm going to reread my question and see what they want me to round to the nearest tenth of a cubic centimeter. Include my units, put a box around my final answer. And again, volume is going to be the easier of the two. Between surface area and volume, volume's easier because you can just find the volume of each separate thing and add them up. The problem with surface area is if I start with this rectangular prism and I put a cylinder on it. Surface area is the idea of all the outside edges. So one of the things that I use to think about surface area is I imagine I am making this beautiful sculpture and I want to paint it blue. So after I've glued everything together and I painted blue, I then think about the surface area and I say, well, if I break it apart after it's painted, can you imagine this bottom part of my Gatorade bottle would still be green because it didn't get painted? And there would be a circle missing from my rectangular prism because it didn't get painted. Because when it was glued together, that's when I dipped it in paint, let it dry. Then I broke it apart again. This bottom part's not painted, and there's a circle missing from here. That's going to be important for us figuring things out because one of the strategies will be find the surface area of this, find the surface area of the cylinder, add them up. But then I have to realize, oh, I have to subtract a circle from the cylinder, and I also have to subtract a circle from the prism. And that's a very good strategy. Some people immediately just start subtracting right from the beginning. So when they do the cylinder, they say, I'm going to do the cylinder without a circle, and I'm going to do the rectangular box without a circle, and I'm going to do it that way. But I kind of like finding each one separate and then thinking, okay, from this one I have to subtract a circle, and then I have to subtract a circle from this one as well, because there's going to be 2 circles that aren't painted when I break them apart. And sometimes, in this first example, sometimes we can also just think about opening it up. Okay? So imagine we have a pyramid on top of a prism here. If we open it up, I'm going to, well, it's a prism on top of a cube. Do you see that a cube would normally have 6 sides? But if you painted this whole thing, only 5 sides of the cube would be included. One of those is 5 times 5 with an area of 25. And we would have 5 of those. Then, for our triangles, for our pyramid, do you see that you're going to have a triangle and you're going to have 4 of those triangles. All 4 of those triangles are exactly the same. In order to find the area of the triangle, you would need the base, which is 5, and the height of the triangle, which is the slant height on the pyramid. Do we know that length? Yes. We know this length is 4. Base times height divided by 2. This area is equal to 10. So our total surface area, if we have one of these is 25 and we have 5 of them, that'll be 125 there. And if one of these is 10 and we have 4 of them, that'll be 40 there. So our total surface area will equal, adding those together, 165, include our units, 165 meters squared. I'm going to leave this next example for you to do on your own. And I'm going to give you maybe 5 minutes right now to try it. So try this one on your own. I'll put up the answer in 5 minutes. And then we have space. Well, we have space, but we're going to do one of the ones from your homework sheet again. So I'll start doing it, see if you have some of the same things, see if you've got some of the ideas right. We're doing the surface area of this. I'm going to label my rectangles. The bottom rectangle is 4 by 6. It would have an area of 24. Next, I'm going to do my sides. And can you see that the sides are not all the same? We have sides that are, if I take the right-hand side, it's 6 by 5, which would make 30. And I have that times 2, which gives me 60. The other side is a 4 by 5, which makes 20. Again, that would be the front and the back. That's times by 2. Just so that I'm kind of consistent, I was like, oh, I kind of like that I'm circling my answers of the pieces that I'm finding. So maybe I'll rewrite that equals 24 and circle it as well. That will be the bottom and the 4 sides. Now we have to go to our triangular prism on the top. And our triangular prism on the top has triangles. And in that triangle, we know that the base is 4, the height is 3. Base times height divided by 2 will give us 6. And do you see that you have 2 of those triangles? That gives us 12. And also on the triangular prism on the top, do you see that you have 2 rectangles? But the problem with those rectangles is you know that the one side is 6. I think did I do that right on my calculator? No, I made a mistake. So I did have it wrong. So I'm going to enter this again. Look at my calculator. It said I didn't use 6. How many people got 179? Okay, good. I'd like to say I'd like to say that I did that on purpose to make you check over your answers and wanna like clarify. But I didn't. I actually just typed in a wrong number. But it's so easy to do that, okay? Now I was trying to do it all in my head, so it shows that if you try to do too much in your head, it's very easy to make a small mistake as you're going. I looked at this length, and because I was doing it quickly, this length is 6. Can you see that that length is 6? But what number is the closest to that length? 5. That's what my brain did. It just moved the 5 there instead of the 6. But the problem with this rectangle is we don't know this side. This side right here, which I'm going to show in purple here, is the hypotenuse. We draw it on here. I don't know that length, but it's the hypotenuse of a right-angled triangle. And so if I want to find that purple side, I look at that right-angled triangle with this purple side. I know the height of that right-angled triangle is 3, and the base is half of 4, which is 2, and I can do a squared plus b squared equals c squared. 9 plus 4 is 13 equals c squared. So this purple side is the square root of 13. So going to my calculator, 6 times by the square root of 13 is 21.63. We have 2 of those. $43.26. Then if I add up all my blue circle numbers together, 100, 124, 136, 179.2, if I add that all up, oh, wrong units. Add this all up and round to the nearest square foot, I get 179 feet squared. Okay? So when you're doing the question, yes, very easy to make a small mistake. Small mistakes are usually like you lose a half a mark or a mark depending on the severity of the small mistake. If the small mistake is what I did, where I just wrote down the wrong number, that's always like, oh, that was just a silly mistake, then you'll lose a half a mark. If the small mistake is you don't know how to figure out the a squared plus b squared equals c squared to get the square root of 13, that's a bigger mistake. That would be like losing a mark. But if your organization is there for the rest of it, you get lots of marks for figuring out and having it organized nice. If you have the big idea, you know what you want to do to add up to the surface area, even if some of your calculations are wrong, you're going to get a lot of those marks because you know what you're doing, you're just making a few small mistakes. Obviously, as we get further along and we get better at our math, what we're trying to do is get rid of those little mistakes, but they're still going to happen along the way, okay? So when you're doing your homework, sometimes it can be frustrating because you look at the final answer and it's a little bit off. But that doesn't mean that you don't have the big idea. So don't get too frustrated from that. Come in lunch, show me your work and say, okay, I can't see where I went wrong, and I can help you with that, okay? But keep working, keep practicing, talk to friends, say, hey, did you get that answer? What did you do? Try to find your little mistakes, because if you find them, then you're going to be less likely to make them again. Because you're like, I made that mistake already. I don't want to keep doing that again. Now, what I'd like to do next is I'd like you to take out the one practice sheet that I gave you, and I would like to do question number 5 together. And it says surface area, right? Yeah. Something like, how did I do? For drawing it, not too bad. This height is 6. The diameter is 5. And the box has 5, 10, 12. So we're going to do this one together, because this is like the idea that I showed you before. We have a cylinder on top of a rectangular prism. And if we want to find the total surface area, we're going to find the total surface area of the cylinder, and then say, oh, but wait a minute, one circle didn't get painted. And then we're going to do this total surface area of our rectangular prism, but then say, hey, wait a minute, there's a circle missing from this as well. So we're going to write out the idea first. The surface area will be the surface area of the cylinder, and then I'm going to write in red minus a circle, and I'm going to put that in one set of brackets, and then we're going to add in another big set of brackets the surface area of the prism, and of course that is also missing a circle, and I'll put that in there. So in red, I'm writing down what has to get taken away, because if you painted the whole object and then broke it apart, there would be parts that aren't painted. There's a part that's not painted on your prism, and there's a part that's not painted on your cylinder. So, you have to decide, and I think this is the hardest thing in these questions, is there's lots of little math that you have to do, and then you have to put it together. So we have to decide how we're going to set this up, and then figure it out. And we want to try to organize that neatly. So I'm going to do this big set of brackets first, and that set of brackets second. So when I go here to number 1, I'm going to write out the idea. I'm going to take the surface area of my cylinder. I'm going to subtract the circle. Do we have a nice formula for surface area of a cylinder, or do I have to break things up? This is one. I have a nice formula for surface area of cylinder. Go to my formula sheet. It's going to equal to 2 pi RH plus 2 pi r squared. Is it written that way, or is it 2 pi r squared first on your formula sheet? Cylinder surface area. Nope, it's written exactly like that. And then I have to subtract a circle . So in order to do the cylinder, do I have the radius? Not exactly. They give me the diameter. Are you okay that we can calculate the radius quickly to be 2.5? Because the whole distance across the top was 5. Did they tell us the height of the cylinder in the question? Yes, the height is 6. Okay? 2 ways you could do this. Some students do this. Put a big or in between. Some students do this. So 2 pi, radius is 2.5, height is 6, plus 2 pi, radius is 2.5 squared, and then they minus pi 2.5 squared. You see that I just plugged everything into that formula? That's perfectly fine. Other students would go, hey, I sort of like, if I have two circles here, 2 pi r squared, and I subtract one circle, that would basically just leave me with one circle. So there's students that simplify this first. Just 1 second left. So we would have 2 pi, our r is 2.56, and then we subtract only one circle, which is pi 2.5 squared. Question?
A lot of the surface area things, they're not on the surface area sheet. It's just like, it says prism. And
Right.
like multiple
Yes, so
surfaces.
that's what makes surface, we've talked about this. So one of the things that makes surface area harder is sometimes you have to just take the shape and break it up. So prisms aren't on your formula sheet because they're just a bunch of rectangles when you unfold it.
I have a question, can I go to the bathroom?
A break is in 25 minutes, so when the break happens. Okay. So we can type either one of these in. The nice thing about simplifying it is there's less to type into your calculator. So you can go 2 pi, the radius is 2.5, bracket, the height is 6, plus pi, and then radius 2.5 squared, 113.8. So we figured out section 1, which was the surface area of the cylinder. I'm keeping myself organized. What do I still have to do? I have to do the second thing, which was the surface area of my prism minus the circle. So this is exactly what you're saying. When we get to this prism part, there's not a nice formula on our formula sheet. So for the surface area of the prism, we have to look at the shape and say, if I am doing the prism, which is like this Kleenex box, there's going to be a front and a back that are both rectangles that are the same. There's going to be a left side and a right side that are 2 rectangles that are the same. And there's going to be a bottom and a top where 2 rectangles are the same. So we can draw them out if we like, and maybe label them the front, back. If I call that my front, it's 5 by 10. My front and back, they'll be 50. Of course, there's 2 of them. That'll be 100. My top bottom rectangles will be the same. I look at my picture. It'll be 10 by 12. Give me an area of 120. Again, there's 2 of them. And my left-right triangles. So I can figure out the area of my entire rectangular prism.
Can I go to the bathroom? I need to go.
You really have to go? Okay. So we have those all added up, right? What do we need to do? We need to do the surface area of the prism minus a circle. So if I put an equal sign here, the surface area of the prism, 100 plus 240 makes 340, plus 120 makes 460. I have 460, and I still have to minus, maybe I'll still write it in red, I still have to subtract pi r squared. So I go to my calculator, 460 minus pi, the radius is 2.5, and it's squared. 440.365. So that was section number 2. And I'll circle that. Right, this was section number 1, this is section number 2. We've got our surface areas of both those sections, so now we can write a statement. My total surface area equals, and I'll just take this answer and I'll add it to this answer. 554.248. What do we want to round to? I'll have to look on your paper, I don't have it here. Does it say what it wants to round to?
Nope.
No, so let's do 3 decimal places. $554.248, and the units were centimeters, square. Put a box around your final answer. If we look at the entire thing, okay? We start off with our idea, and then we have to be organized. This section of this unit's really about organization. We have to be organized to be like, what do I need to find? And I labeled, I'm gonna find this first, then I'm gonna find this second, found it. Then to get the total, I just needed to add section 1 and section 2 together, and I have my answer, okay? It's easy to get lost if we're not organized. It's easy to forget a side if we're not organized. So one of the things you're practicing is just, how do I organize my math to make everything fit together here nicely? Okay? So last 15 minutes, I want you to work on that worksheet. There's also some questions in the textbook to do.